The last time we have written this VHDL code, we have compiled it and we have simulated it in ModelSim using by giving the values for A, B, and C using the clock. That is, we had to modify the wave for different signals and we had to put them on the wave editor. But that isn't efficient. And now I'm going to show you how to write the test bench. To write the test bench, you do not want to write the test bench in quarters. I mean, you can write it, that's not a problem, but your test bench is not going to get synthesized, which means your, your since your test bench does not have any logic gates or input ports and output ports, it's not going to get synthesized. So what I prefer to do is I'm going to leave this as it is because if you're doing the FPGA programming, you need to assign the pins and program the device. But if I'm only concerned about simulation with it and checking the test bench, I would open ModelSim directly without going through the tools and RTL simulation. I open ModelSim directly. Okay. Now, what I'm going to do is I go to File, New, Project. I'll name the project as something random. That's fine. I'm going to browse to the same location where I saved my original. So that's click OK. I'm going to add the existing VHDL file that I created. So browse, that's my circuit. And I'm going to create a new file and I will name it as tb_funk. That was the entity name for the test bench that we have written. And make sure that the file type is VHDL and click OK. Click close. Now double click on tb_funk. The editor opens up. This is where you can write your program. Also, you can open your original circuit to the side just in case you need it for access. Now I can start writing my test bench. So library IEEE use IEEE dot std underscore logic underscore 1164 dot all entity tb_funk is and architecture test bench of tb_funk is. Now, what I'm going to do is I copy the whole entity of my circuit and paste it here and remove entity and put component and write end component. Now I can declare my signals A, B, C, and F, std_logic. Then I say begin. Uh, you can write either DUT or UUT. Call the function my circuit, plug in the inputs. So you use port map A, comma B, comma C, comma F. Then you can write inputs, process. Then you can say begin. A equals 0, B equals 0, C equals 0. Then I say wait for 10 nanoseconds. Let me make copies of these. So you'll have 8 combinations in total. So that's 2 combinations, 3, 4, 5, 6, 7, 8. Let me fill out the values. In this case, it would be 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And then wait and process and end. Save it. First, you would want to compile your my underscore circuit.vht. Remember, it was already compiled on Quartus, but I'm just opening ModelSim explicitly as standalone. So compile. So compile of my circuit.vht was successful. Then compile your test bench. So compile of test bench was successful. Now, the next step is to simulate your test bench. You do not you do not simulate your circuit, but you simulate your test bench. Remember, your test bench is calling your circuit. So that's automatically it invokes a circuit. So select the test bench, click on simulate, start simulation, work, test bench underscore func, and click OK. So it gives you the wave. Click on all the 4 signals here. Click add wave. And remember, here we have 10, 10, 20, 30, 40, 50, 60, 70, and 80 nanoseconds, up to 80 nanoseconds. So in this case, I would set my simulation to 100 nanoseconds and then click run. Click F. So zoom out. Okay. Now, initially, all your inputs are zeros and your output is 0. Now, one of your input went to 1, so 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. See how convenient it is to search for inputs and outputs. You can just verify sequentially. Whereas in the other case, you had to look for different combinations like 000 or 001. It used to be very problematic. So a test bench is a very neat way of doing it. And in the industry, they always use test bench. So this is something that you need to get used to as well.